Hello, this is question 3 on your AS level from June 2022 paper, from the statistics paper. And I think it's a very interesting question. It's not that common what they ask. So you have a histogram summarizes the height of 256 seedlings 2 weeks after they were planted. Use linear interpolation to estimate the median height of the seedlings. The first thing you have to do with these histogram questions is to check that the area is really the frequency, because in many questions the area will be proportional to the frequency or the frequency proportional to the area, but not equal. So you always have to check just in case, because they could be a coefficient, they could be scaled. So what you have to do is to find the areas of all of these bars and check if that area is equal to 156. And this is the case in this question, but you have to check. So the area of this one is 1 times 15. So this is 15, this is 35. So you add them all and you will see that it's 256. Yeah. Then you can read the values straight from the graph. Otherwise, you will have to consider that coefficient. Use linear interpolation to estimate the median height of the seedling. So we have 256 values, which means our median would be our 128th value. So we need to see in which interval of these our median is. So we have up to here 15 values, right? This area. So we have 15 values up to here. Then we add another 35 and we have 50 values. Then we add this area here is 1.5 times 50, which is 75. So we are in 125. Sorry, not here. So here is 125. Then we add 1 times 55. And this is 180. So that means that our 128th value is somewhere here between 125 and 180th value. So this is the interval that I'm going to use to find the median and to do the interpolation. So to do the interpolation, I'm going to write in the next page. So I'm going to do this thing here. In one side, I'm going to write the order. So I have my 128th value and my 180th value, and I need to find my this is 125th, and I need to find my 128th. And in the other side, I'm going to write the limits of the interval. The limits of the interval, this interval, because I'm working with this one, is going to be 3.5, 4.5, right? So 3.5 is this value, 4.5 is this one. So 3.5, 4.5. And this is going to be my Q2. Be careful with the histograms, because sometimes you have to consider when the values have been rounded. So instead of counting things, sometimes you have rounded something to the nearest centimeter or something like that, and then the limits of the intervals could be slightly different than you think. So just be careful. And now I use interpolation. So this distance divided by this distance is going to be the same than this distance divided by this distance. So Q2 minus 3.5, Q2 minus 3.5 divided by 4.5 minus 3.5 is going to be the same that 128 minus 125 divided by 180 minus 125. And from here you find Q2. Q2 is 3.5545. And they ask, they don't ask us to round to anything in particular. So I'm going to say, for example, 3 significant figures. So I'm going to leave this to 3 significant figures. So that's my median. Then they say, and this is what is less common in these questions. Chris decides to model the frequency density for these 256 seedlings by a curve with this equation. So it's a quadratic, and this quadratic is going to be defined between 0 and 8. So that means we are going to substitute this histogram by a quadratic between 0 and 8. Yeah, something doing that. We need to find the value of k. So with these frequency density curves, the area under the graph is going to contain all the 256 seedlings. And that's what you have to remember wherever you have to find constants. So the area under my graph is going to be 256. And that's what we are going to do. It's a quadratic. The area under quadratic is going to be the integral. So we are going to integrate between 0 and 8 this function. And we are going to make that equal to 256. So we have the integral between 0 and 8. I'm going to write the k outside. I have x, 8 minus x, the x, and I'm going to integrate this. So I'm going to multiply, so 8x minus x squared, just the brackets. And that way, this is k, and 4x squared minus x cubed divided by 3. Between 0 and 8, I substitute the 8, and I have k, 256 minus 512 divided by 3. When I substitute by 0 is 0, and then I have this is equal to the total number of seedlings, which is 256. And from here, you have that k is going to be 3. Yeah, so this just dividing this by this thing. Yeah, and then the last bit they ask is, using this model, write down the median height of the seedlings. This graph, so we are substituting our histogram by a quadratic. The quadratic is symmetrical. That means the median is going to be the midpoint just by symmetry. So if I'm representing my quadratic between 0 and 8, so you have, see, you have your quadratic between 0 and 8. This is 8. Your mid value is going to be this one. Yeah, it's going to be 4. So my Q2 using this model is going to be 4, which is not too far from the one that we found using the histogram. Yeah, and that's all. That's with this question.